Hello, everyone. Thanks for joining the session today on predictive asset maintenance using Heatwave Lakehouse. Collecting data is the first step. The true value begins when you use it in real time to take insightful actions. So only data silo is not the problem. How you will get the insightful information in the real time. So we will see using the Heatwave how we will achieve that, and we will discuss about other OCI services as well. So Oracle, we have building innovations and technologies for last 47 years. We have invested $72 billion over last 10 years in the R&D. And we are one of the 4 hyperscaler leaders in the Gartner Magic Quadrant for cloud platform services as well. So what is data lakehouse? When you have the beauty of both data warehouse and the data lake. So it's the data lakehouse. But if you have hundreds of sources, then how you will integrate all these so that we can get the insightful information. So in this solution, we will use Heatwave. That would be center of this solution. And why Heatwave? When we talk about the other lake houses as well. So we have the best price performance and the performance as well. It's efficient processing for data lake because everything is in memory when it's coming from the object storage. And we are the only cloud provider which have the enterprise edition available in the OCI. So inbuilt Gen AI, and it's available also in the multi-cloud. So this is our modern data platform architecture, and we start by ingesting the data from the sources. And we have a diverse sources. It can be your on-premise database. It can be your any of data, like it can be your SAP, it can be your Snowflake, and it can be your any other cloud data as well. So we integrate those sources using our integration services, which is streaming services. We have the data flow, and we have the golden gate for the real-time replication. So when we integrate with the sources, then firstly in the data store, we have our raw data layer, which is called the bronze layer. So whatever that streaming is coming from the IoT devices, we store that as it is inside the raw data. And we will discuss a use case like which streaming IoT devices we are talking about, and I'll show a demo also in the last few minutes. And once you have the data inside your bronze layer, then we can clean, filter, and transform those data, and we can keep that data inside our silver layer. And once you have your data inside the silver layer, then in the center, we have the MySQL Heatwave Lakehouse, which is our gold layer. And in this gold layer, your data is ready for taking any business decision, and you can take your decision according to that. And we have the advanced analytics. And in the advanced analytics, you will have your dashboards, and you can have your AI ML also. So you can utilize business-ready data from the gold layer. So in the maintenance, there are 3 strategies. One is the reactive, preventive, and the predictive. So reactive is the break-fix approach. So it means something is failed, only then we fix that. So enterprises who have the and if any asset is being failed and it doesn't impact their business operations, so those enterprises maybe choosing the reactive. And in the preventive, what happens? It's a scheduled maintenance and based on the routine checkups. So on the regular interval, you have to take the maintenance of your assets. So what happens? Even if it has remaining useful life, you have to replace that asset. It means you are not fully utilizing the asset's lifespan. So it's based on the time and uses, and it costs moderate cost and downtime as well, because your asset is still running and you will ask for some downtime, and we want to have some maintenance on this line. Then you are bringing down, already it's running, so it's impacting your operations also, because it's not justified. Like something asset is working now and you want to take a downtime, you need maintenance. Still it's having its useful lifespan. So here comes in the predictive maintenance. So it's more on the data-driven maintenance and the real-time condition-based. So it requires the downtime when it's near to its end of life. So you do not need any downtime, regular downtime. You do not need that. So it means no earlier, no later. So when it's required, then you will take a downtime for your maintenance. So here are the few industries use cases for the predictive maintenance. In the manufacturing, we can predict useful life of assets. And in the transport, you can reduce the equipment failures. In the healthcare, for the ventilators prediction, you can use that. In the aerospace, so you can have the predictive maintenance for the aircraft, and when you need maintenance, it can predict. So you can smooth your operations of the airlines as well. Warehousing, you can have the prediction when your conveyor belt need the maintenance as well. So similar way, you can, in the railways, you can predict the wheel or brake wear when you have to take some actions for the maintenance for that. Because of poor maintenance, 82% of companies have had unplanned downtime that cost around 260K per hour, and the average of the outage was around 4 hours. So key challenges for the manufacturing business, we are going to deep dive for one of the use case also. So we will discuss about how we can build that technologies from ingestion of the data till the analytics dashboard, how you can view that. So how can I predict asset failures before they happen? How can I reduce the unplanned downtime? And how I can better manage my inventory? And how can I secure and safety and the compliance in the real-time monitoring? And how can I better utilization of the resources across the plants? So let's see what is the solution for that. So how can I do? Yes, you can. Yes, you can with MySQL Heatwave on OCI data platform. So here we have manufacturing units in this architecture, and IoT sensor continuously sending the data. We call it events. And there is a OCI streaming service. And this OCI streaming service, it's capturing the data which is coming from the IoT devices. And then using the connector hub, we are passing those events to the function. So let's go by block. I'll explain you what are these services and what these services are doing. So in the first block of the streaming is capturing the data which is coming from the IoT devices, and streaming is the Kafka compatible API, and those applications which we have built for the Kafka, that's the compatible with the streaming as well, and using the connector hub. So connector hub, what it does, it integrates the OCI services. So function, we are utilizing here, so function is the platform where you can run your code, and you can run your code on a serverless platform, And this function is part of the FN project. So FN project is the open source, and you can run this FN project anywhere, in any other cloud or even on the on-premise also. So this is the container-based. So when we are executing the code, then you are going to be charged only for the duration this code is being executed. Once the execution is completed, if the script was running just for the 2 seconds, so it means you have to bill around that only. So these functions call the ML endpoint. So from the IoT devices, we are capturing the data like temperature, rotation speed, torque, air temperature, etc. So when this function is passing this information to ML API endpoint, so it gives the prediction score. This model has been trained on the historical data. And based on that historical data, it gives a prediction score of probability, what are the chances is going to fail. So after processing those raw data, it gets a score also. So now function has both prediction score and the asset details. So for the real-time information, if user can query that, so it's writing in the MySQL Heatwave. And it's parallelly writing inside the batch layer object storage as well. We are storing in the object storage, so later, hourly basis, it can aggregate the data. So data flow is Apache Spark-based processing unit that's doing some calculation. It's calculating hourly basis, what is the average of the temperature, torque, and air temperature, and what are the other parameters. So it's calculating the average. Apart from that, it's also calculating the probability also. If there is a probability of 60% of failure, then it will send a warning. And if it's like 90% or above, then it will send the notification so that action can be taken. I'll show you the demo also, how we are doing that. So in the silver zone, when the data flow has done the aggregations, then it will store in the silver zone. And if any customer has the asset management system also, so we can integrate that. Using the asset management system, we can get the information about the suppliers, your current inventory. So we store that information also inside our silver zone. And data catalog service, it's useful if you have a lot of data, whether it's storing inside object storage, in MySQL database, or any other database, you can integrate that. And you can find the data, where is the enterprise data is there. So it's a data discovery tool. You can find your data so that data scientists can build, train, and deploy their models as well inside the data science service. So after having all the data from the asset management and from IoT devices, after processing and after having the useful business data, we store everything inside the MySQL Heatwave. So here we are solving both of the problems. The real-time data now inside the MySQL, and we have the asset data also. For example, if any of the asset is going to fail and there is a probability of the 90%, then automatically a PO will be generated and it would be processed further. So no need to manually have the inventory management also. So whenever it's required, so as per the percentage of probability failure, you can take the decision for that. So this is our asset dashboard, how it looks when we integrate the complete data, whether it was coming from hundreds of different sources and from the asset management or from the IoT devices. So here we are having the 72 assets in this dashboard, and it's performing the same role. And number of asset by location, we can see it's 18, 24, and so on. And expected end of life is from 3 to 12 months. And we can see one of the manufacturer, we have the total 3 manufacturer here. So one of the manufacturer who starts supplying in 2022, those are the 9 asset currently we are using, and only in the stock on the right-hand side on the below, we can see only we are left with the 3 units. And we can monitor the performance of the supplier. This particular supplier is not performing well because recently they supplied 9 asset in 2022, and we can see the expected end of life for that particular supplier is not good shape. So we have to think about that supplier. So this is the probability of failure by location because we were having our asset in 3 locations, and this is the probability that we can see in the middle. And probability of the failure by the manufacturer, we can see what is the probability. So we can see that particular supplier on the right-hand side. Suddenly after the October, there is a rise in the line. So it means something is wrong with that. So we need to, because now you have some data points. Recently, they started supplying and they need more asset from them. And its probability of failure is also high. And this is for one particular asset, and asset ID is L47230. So we see the performance of that, like probability failure is suddenly increasing after 11th in that month. And torque also suddenly we can see after the 11th, it's coming down similar with the tool wear also. So it means there is some issue with this particular asset. This is the asset performance dashboard. And we can see the temperature by location for that particular asset and rotation speed, and all you can monitor. Again, we see in this dashboard also, it's indicating there is some issue with that particular supplier assets. So you can monitor the performance of your supplier as well, apart from your inventory management and the prediction also. So for this, whatever I have discussed, we have built a live lab also, and it's available to the Oracle Live Labs, when you will see, and you can do end-to-end pipeline from ingesting of the data till the analytics dashboard, you can do yourself. It's a longer live lab, and at least it will take a full day. And now I will show you the demo also. And this is a recorded demo because it's end-to-end flow and it was not feasible to show here. So let me play that. So before starting, firstly, let's see what is the real-time count inside our feed data table. So it's 13636. And this is the script model deployment, which function would be calling on this endpoint. And this producer code loop script, it's generating the dummy data like it's being generated from the IoT devices. So these are the simulated. So we are gathering the timestamp, asset ID, temperature, torque, and other parameters that would be processed by the model endpoint. Oh, sorry.
Exactly, to the other side, because it's extended. You can change it, yeah. Over here, that's the same spot. Change. And then, there you go.
Okay, sorry. So is it visible now? So here is the total count inside the table. It is currently 13636. And now we will run our script of model deployment, and that will give the endpoint to the function that will be processing this raw data which is being generated from the IoT devices. Now I'm going to run this script, and these are the dummy data, asset ID, timestamp, and device type, temperature, air temperature. And look at the timestamp. And this is continuous recorded, and this video was not paused when it was made. And look at the timestamp also, whether it's in the real time or not. I'll show you at the dashboard also. So this is the model endpoint. And this is the streaming service dashboard, which you can see the messages are coming. This is for last 7 days. And these are the metrics where you can monitor what messages are coming inside the stream. And this is the connector hub, which is passing those stream information to the function. Then this function will call to the ML endpoint for the prediction score. So for last hour, let me see, because I'm running the script. So yes, we can see the messages. It's receiving the messages. So these are the other parameters. So this is the ML endpoint of the machine learning. So it's processing. We can see 200. So it's processing the continuous data which is coming from the sensor. Now we can see the count is increased. Earlier it was 636. Now it's 763. So it's coming inside the Heatwave on the real time. And it processed from the ML endpoint also. So we will see like how quickly it's generating the timestamp also. I'll show you. So here it's key processing ML endpoint, and it's receiving the data at 9:46 p.m. and it's going on. And these are the IoT messages which is being generated, and the current timestamp is 9:46 and 40 seconds and so on. Okay, I'll show you the dashboard also. And this is the live dashboard. And let's firstly go to the asset dashboard, which I was showing you earlier during the slides. So this is the number of assets. And manufacturer, like when we have purchased from them, because that has been integrated with the enterprise asset management system as well. So that's capturing the data from there. So probability of failure by location, which we were going through, so we can see in this dashboard as well. And the asset details, probability failure, and this is the performance dashboard. So this is our Oracle Analytics service from where we are developing these dashboards. So now let's look at the timestamp, whether really it's having the real-time data. So currently time is 9:47 p.m. 30 seconds. And we can see the IoT also similar, 9:47 and 48 seconds. So it's the real time. So you see here, we generated the data from the IoT devices, and then it was captured by the streaming, then executed by the function code. And those function code call the ML endpoint. And after that, function backed those information to the MySQL and the object storage. Now we can see in the real time all these being occurred. When I reflected to that screen, already the data was there in the dashboards. So this is the beauty of the Heatwave. And whether you're having your data across hundreds of source systems, anywhere, any cloud, on-premise, so we can ingest all this data inside the MySQL Heatwave, and every query would be executed in memory. So, okay, this demo has been completed. So if you have any questions, so you can ask me.